Hey everybody. Today what we're going to do is we're going to look at if we are given a determinant of a matrix and we change things with the matrix, how we're going to see how that affects the determinant we were given. All right, so we're going to look at some of the properties first before we get into an example. All right, so what you see on the screen is a screen grab from the elementary linear algebra textbook. So we're going to look at through these three effects on the determinant when we perform elementary row operations on the matrix we were given. So okay, so if we multiply, let's look at the first case. So if we multiply one row of our original matrix by a constant, then the determinant will change and you have to multiply the original determinant by the constant. Also, so that's our first elementary row operation. If we multiply an entire row by a constant, the determinant is also multiplied by that constant. So in this one with the original, we had row 1 goes to k times row 1. So now the determinant is now k times the determinant of the original. So in this one, we have a row switch. So in here, row 1 went to row 2. And for every time that we switch a row in a matrix, the determinant of that matrix has a switch in the sign. And our third case is if we add a scalar multiple of another row to a row. So if we have, if we took row 1 of our original and we added and we made it and we operated it to change it to row 1 plus k times row 2, this would have no effect on our determinant as we are adding a different row. However, if we were adding the same row to itself, this would actually be a scalar multiple. So this would be that case, and you would have that would change the value of the matrix, of the determinant of that matrix. So this case is only true when you add a different row. But if you add the same row, that's basically multiplication. Because, well, obviously multiplication is repeated addition. So we're going to look at a case here. All right, so let's go through our example. Okay, so if the determinant of our original matrix is 67, we will find the determinant once we've operated with elementary row operations to get this matrix. So let's interpret this as the final operated matrix, and we're going to go step by step, and we're going to have the original determinant equal to the determinant of the original matrix, and we are going to change this matrix until it looks like the stuff here. And while doing so, we are going to be mindful to change the left side of the equal sign as well. So let's go through and find our scalar multiplication first. So I see some subtraction. We're going to ignore that for now because we know that's like subtracting a different row. And I know that's not going to have any effect on my determinant. So we're going to ignore that for now. I'm not going to fully cross it out because I can erase it later and see it. So first thing I notice is, well, you can notice whichever you want first, is that we have a 5 attached to each number of the first row, which means the entire first row was multiplied by 5. So row 1 goes to 5, row 1. All right, so this would give us 5A, 5B, and 5C. I'm going to try to do this in less steps than I would usually. I also notice that the D, E, and F have a -3 attached to them. So, and they each have that. So I know that my row 2 has been scalar multiplied by -3. So that would give us -3 D, -3 E, -3 F. We have our G, H, and I. So our determinant is going to change. It's not going to remain this number, unfortunately. So we have to multiply each of our scalar multiples. We're going to have to multiply each of those by our determinant to get our new determinant. So if we multiply an entire row by 5, we would have to multiply the determinant by 5 as well. And since we multiplied an entire row by -3, we would also have to multiply the entire determinant by -3. So let's keep going. I also know that my D, E, and F are now in the bottom row, and they started in the second row, which means that there was a row switch somewhere. So that changed row 2 to row 3 and row 3 and swapped them. And I know that this will, obviously this will give me 5A, 5A, 5C. And we have G, H, and I here instead. And we have -3D, -3E, and -3F. And since I performed a row switch, my determinant will change sign once again, or once. So we have -1 times -3 times 5 times 67. And so now we're going to address our subtraction. So since we are subtracting, adding or subtracting a scalar multiple of a different row results in the same determinant, I know that the determinant of this matrix will be equal to the determinant of the matrix in question, which is, hang on. So I know that this will be equal because I know that adding or subtracting a scalar multiple of a different row will not change my determinant at all. So now I can do some arithmetic and evaluate my determinant. So we have 15 times 67. Obviously, you're probably going to be given, depending on whoever makes your test, you're gonna hope that you get a friendlier number to work with. But depending on your background, you probably have some good experience with basic arithmetic, hopefully. Sorry, breathing. All right, so I'm gonna leave my calculator away. We have 10 times 67 plus 5 times 67. Hopefully we know how that works. That gives us 670 plus 60 times 5 plus 7 times 5, which gives us, obviously you can stack them, do the thing that you learn, or you can use whatever strategy you picked up through your career. So this is 120 and 35. We have $790 plus 3. So you just ask your belief system to give you a friendlier number to work with. This gives us 825 as our new determinant. So yeah, so basically the take home is just that multiplying a row by number makes you have to multiply the determinant by the number, and then for each row switch you have to switch the sign. So in this example we switched rows once. If we did it twice, obviously this would be positive because there would be two negative ones multiplied by each other, which will give us a positive one. And then either hope that you've brushed up on your arithmetic enough to finish in time, or that your whoever is creating your assessment gives you a set of friendly numbers to work with. All right, so hope that helps with your work, and I wish you the best of luck and have a great day. Thanks for watching.